I don't know why I shut it off. Intensity is the energy divided by area times time. Intensity is the amount of energy passes through a given area in a given time. And since power equals energy over T, intensity will be power over area. Now, since the sound travels in all dimensions, not just in two dimensions, I'm drawing on a piece of paper in two dimensions, but you got to visualize this, that's a sphere. It comes in all three dimensions. So when you look at the sound coming out, you got to see it like this. I don't see it, but like you got to visualize the sound coming from the center. Can you see it's like it's supposed to be 3D, like a basketball? So the area for a sphere, the area, it's 4 pi r squared for a sphere. We're not dealing with drop of water on the surface there. We're dealing with 3D here. If there's a drop of water on the surface, you're right, the area will be pi r squared. But because that's a 3-dimension, anyone actually within the same distance from that point, anywhere sitting can hear that sound. Not just the ones on the ground, the ones on the side, the ones up in the sky, anywhere. So the intensity becomes power divided by 4 pi r squared. If we're dealing with 2-dimension only, 2D only, like again, you have a liquid, you drop a straw in it, you see the wave travel, that the intensity of that wave will be power over area. But if you're dealing with a 2D only, that drop that you put in the water there is going to have an area of pi r squared. But now when you have a speaker or a sound is actually a 3D here. The sound travels in 3 dimensions, in the x direction, in the y direction, and up and down t direction. Not just on the ground, also in the air. So that's the equation that we use actually. So now, I forgot to snap the notes there. It's going to screw things up. I got to remember to put a note for myself. Again, we have a speaker making noises here, and somebody is 1 meter away, and somebody else will do 4.2 meters away. The intensity here for that problem, what was it? What was the intensity I gave you? 2.8 times 10 to the negative 6. What is the intensity right here? Oh, shoot, I forgot to do something else with that. Okay. So now, intensity, it's power over 4 pi r squared, or area. Power equals 4 pi r squared times I. 4 pi r is what? R is 1, square it, times the intensity, which is 2.80 times 10 to the negative 6. It won't change my intensity the way I did it before. My answer is going to be the same for the intensity, but the power will be wrong. 4 times pi times 2.8 e to the negative 6 5.2. If I know the power, that doesn't change. So the intensity for the person sitting far away is going to be the power over 4 pi r squared. The power is 3.52, 10 to the negative 5, over 4 pi times r, which is 4.2 squared. Uh-oh, 3.52 e to the negative 5 divided by 4 divided by pi divided by 4.2 squared. Oh, I got a syntax error. Go to 4.2 squared. It's the same number. So the intensity doesn't really change. That's because the 4 was in both of them, so it cancels each other out mathematically. That's why. But I was looking at it in terms of water. You're dropping something in water traveling in one dimension. The way of looking at the wave from the surface. We know that sounds, actually, if it's sound, that sound travels in all dimensions, not just in 2D. In all 3 dimensions, there should be 4 pi r squared, which is 0.159 times 10 to the negative 6. The reason I like to put it in this format to show you, it went from 2.8 to 0.159 or 16. So not much left of that noise there. And if you move 2 more feet farther, you probably can't hear it. Let's try another one. So here we have a baseball player. We'll say a Big Papi. Don't like him, but hits a home run or hits the ball. And you are sitting in the bleacher section. Your distance from where Big Papi's standing is 140 meters away. Approximately about 470 feet away. Papi hits the ball. Now you hear the sound, the bat hitting the ball. Intensity here, you the fan, you hear the intensity of the sound here to be 3.8 times 10 to the negative 7. Watts per meter squared. And the same type of a question, what is the intensity heard by the guy? We'll say the second baseman or the first baseman. We'll do the first baseman. First base. Now the first base usually is sitting, if you played baseball, you know the diamond is what, 90 feet by 90 feet by 90 feet? Yeah. So it's 90 feet. This guy is 90 feet away, which is approximately 90 feet. Convert that to meters, 27.4 meters roughly. So what is the intensity there? Same story, just like the birds there, or the speakers. I can calculate the power. Knowing the power, use that power to calculate the intensity for the first baseman. So for the person sitting out there, that's in the bleacher, that's you. The intensity is the power divided by 4 pi r squared. The intensity is what? 3.8 times 10 to the negative 7 equals the power unknown 4 pi times r squared. What is r here? 140, and you're going to square it. The power is going to be 4 pi times 140 squared times 3.8 times 10 to the negative 7. What I say is out beside Alex today. Oh, Corello. Times 3.8 e to the negative 7. I got power 0.094. So the intensity now at first base is going to be the power divided by 4 pi r squared. The power is 0.094. 4 pi, and r here is what? 27.4. Divided by 4, divided by pi, divided by 27.4 squared. The intensity is 9.92 times 10 to the negative 6. Much stronger sound than if you were sitting in the outfield there, or in the bleachers. Notice that's 10 to the negative 7. That's 0.38. This is 9.96. Now, if you're working actually with heavy equipment, you'll see these people wearing these, like if you're constantly mowing the lawn, you see the guys who mow the lawn wear these earmuffs on them. You know, they have to, otherwise they'll be deaf soon. And I fly a plane, everyone knows that, single engine plane, so I have to wear these headset, which block almost 90% of the noise, because the noise of the engine running is really loud. So if you don't put the headset on, you can't hear anything. And after a while you go deaf, and the other side of it, you'll be yelling at everyone just to hear what they're saying. So they muffle the noise, they eliminate the noise. We measure the noise by decibels. We use beta. And beta here, so this is intensity level in decibel there. And we call the intensity level, we call that beta. So beta equals the 10 times the log, that's log, the log of I to I sub 0. And I sub 0 happens to be 10 and to negative 12 watts per meter squared. The intensity, the threshold intensity, which is 10 to the negative 12. That's really what I sub 0 is. So it depends on the sound is. For example, if we have something running at 10 times I sub 0, 10 times I sub 0, if you let I equals 10 times I sub 0, that's the lowest level you can hear. So if you let I equals 10 times that number, then in decibel, that value is going to be 10 times the log of 10 I sub 0, because 10 times I sub 0 over I sub 0, which is 10 log of 10. Log of 10, if you know anything about trig, that's 1. So 10 times the 1, which is 10 decibels. dB, decibel. Actually, we always write small d and capital B. Decibel always small d, capital B. Again, if you have a calculator, if you go to the log, there's the log, L-O-G. The log of 10, you should get a 1. If you go 10 times the log of 10, it should give you a 10. So we measure sound in decibel. Decibel, by the way, doesn't have any dimension. It's a ratio of intensity to intensity. So the unit, they cancel each other out. So it has no unit for decibels. So I sub 0 is the lowest noise that you and I can hear. That's what I sub 0, the threshold. Now actually we range from what we can hear. I'll give you some numbers in a minute. What number will make you go deaf? If it exceeds, I think, 120 decibel, you puncture your eardrums, you're done, you'll never hear again. Yeah. Let's take an example with decibels here. Hopefully, because you're still in college, you know, you don't have a lot of kids at home. But here, a crying child. So we have a baby cries. Here we go. That's the baby crying. The sound coming out of his mouth, her mouth, screaming. The intensity of the crying is 8.0 times 10 to the negative 6 watts per meter squared. And we want to know what that number in decibel. Find the intensity in dB. The intensity in decibel is going to equal to 10 the log of I over I sub 0. That's the equation we just gave you, which is 10 times the log I, which is 8.0 times 10 to the negative 6, divided by I sub 0, which I just told you that's what? What is I sub 0? 1 times 10 to the negative 12, right? So what's that number? 8.0 e to the negative 6 divided by 1 e to the negative 12. That's 10 log 8 times 10 to the power of 6. Take the log of that. The log of that number, 10 times, this will be 6.90, so this will be 69 decibels. Now imagine if you're having twins here, and they're both crying. That's the sound coming out of their mouth. They're both screaming. They're hungry. And let's assume I equals, I don't know, twice that number. Identical twins, each one making 8.0 times 10 to the minus 6. Let's make it twice that number. 16 times 10 to the negative 6. So twice that number. So in decibel, what you're going to hear, it's 10 log 16 times 10 to the negative 6 over 1 times 10 to the negative 12. Simplify this, that'll be 16 times 10 to the 6, or 1.6 times 10 to the 7. Take the log of that. 1.6 e to the 7. It's 10 times 7.2, and that's 72 decibels. So in terms of decibel, the noise only went up by 3 decibels when you have twins. I have a chart somewhere. Oh, here we go. I knew there's a chart. Ready for these numbers? This is the chart. The lowest noise we can hear is 0 decibel. That's the threshold. I sub 0. Why is it 0? Because if you do I sub 0 over I sub 0, if you do I sub 0 over I sub 0, that's a 1. What is the log of 1? 0. 0 times 10 is 0. So the lowest noise you can hear is 0 decibel. Okay. Whisper is 20 decibel. Classroom, me talking, 50 decibel. When people talking, 60 decibel. Heavy traffic, 70 decibel. Subway, 100 decibel. If you go to a concert, 110 decibel. 120, start to feel pain. Jet taking off, you were next to the airport, you hear the plane taking off, 130 decibel. Eardrum ruptures, 160 decibel. Once that noise hit 160, you're deaf. So 120 and up, you start to feel some discomfort. Cool numbers.